Good morning, everyone. I am Sangeeta B from the Department of CSE IoT, working in SNS College of Engineering. Today, we are going to see what is relational database. A database is a collection of irrelated data and a set of programs that allows the user to access and modify these data. A major purpose of database is to provide user with an abstract view of data. This is simply hide certain details of data that are stored and maintained. In this, what is we are going to explain in this video is first thing we are going to see about view of a data, how we are viewing a data. For example, I'm having a large number of data that is related to the college or a hospital. I can only see whatever the things I wanted, that is who is the patient admitted here in today's date and what are all the operations as scheduled. I can see only that data, and balance other databases are hidden back, and that's we are saying it in a view of data. For this, we can say that the data abstraction for the system be usable. It must be retrieve data efficiently. The need for the efficiency had lead designer to use the complex data structure to represent the data in the database. Since many database system users are not computer trained, developers hide their complexity from the user through several levels of abstraction to simplify the user interaction with the system. Here we have a three concept, that is external schema, conceptual schema and the internal schema. The first thing is internal schema. In the internal schema we can see the coding and the database stored and the methods of database stored and all that. In conceptual schema it is like an interface that acts between the external and the internal. It will be processing the input from the external and will be processing the output from the internal. The external schema is nothing but the things we see in the database. The queries output, it is all said to be an internal schema. First one is the physical level or the internal view or a schema. The lowest level of abstraction describes how the data are actually stored. In the physical level, the lowest level of abstraction describes how the data are actually stored. The physical level describes complex level data structure in the details. Next one is the logical level. The next higher level of the abstraction describes what data are stored in the database and what relationship exists among those data. The logical level thus describes the entire database in terms of small number of relatively simple structure. Although the implementation of simple structures at the logical level may involve complex physical level structure, the user of the logical level does not need to be aware of this complexity. This is referred to the physical data independency. The database administration who must decide what information keep in a database use the logical level of abstraction. The next one is view level or an external view or a schema. The highest level of abstraction describes part of an entire database. Even though the logical level uses simple structure, complexity remains because of variety of information stored in large database. Many users of the database system don't need all this information. Instead, they need to access only the part of database. The view level of abstraction exists to the simple their interaction with the system. They may provide many views for the same database. Shows the relationship among three levels of abstraction. An analogical to concept of data types in programming languages may clarifies the distinction among the level of abstraction. Many high-level programming languages supports the notation of structure type. For example, we may describe the record as follows. The type instructor equal to record. In type in record we have ID, name, department name, salary and the aim. In this coding, the new record is called as an instructor with 4 fields. Each field has a name and a type associated with it. For example, the ID is a character type and its size is 5. And next one, the name is a character type and its size is 20. The department name, the character is 20. The salary numeric is 8.8, 2. Because for what purpose we are giving it as a 8.2 is in 8 digit the salary will be credited and the 2 will be in the paise. So we are setting the data size as it's applicable. The university organization may have several such record type including database disk level, that is department with field, department name, building and budget. Course with the field, course ID, title, department name and credit. Students with files, ID, name, department name and total credit. Thank you.